Hi class, let's start lesson 3, permutation with restrictions. In many problems, restrictions are placed on the order in which objects are arranged. In this type of question, dealing with restriction first, many of the problems in this lesson can be solved by fundamental counting principle. So again, they state the same thing. If the permutation helps you, use it. If it doesn't, you don't need to. All right. Answer the following question using the following. How many ways can all of the letters orange be arranged if there's no further restriction? Okay, well, this question, according to lesson 1, we know, okay, you count the number of letters. There are 7 of them. So you want to arrange 7 letters, right? So it's 7, 6, 5, 4, 3, 2, 1. So lesson 1 will do that. In lesson 2, we learned that this is same as arranging 7 objects. So it's 7 factorial. So it's the same. So either way, you don't need to show one way or the other. Okay, this is same as 7p7. All right, they are the same. The first letter must be N. All right, so there's only one choices there. Right, the rest is 6, 5, 4, 3, 2, 1. All right, so you can just do that, no problem. Of course, you can write 1 times 6 factorial. The interpretation is this. Okay, first I need to put the N there. The remainder of the question is I need to arrange 6 objects. That's why 6 factorial. All right. So you don't need to write that, but you could if it's help you. 3 girls, 4 boys are arranged in a row. How many ways can this be done if there's no restriction? All right. Well, how many people there? There are total 7 people. So the answer is 7 factorial. You're just arranging 7 people, right? You can write 7, 6, 5, 4, 3, 2, 1, or just write 7 factorial. It's the same thing. The photographer decided he could take a better photographer if no two people of the same gender can sit together. Well, how can you arrange the student? Well, to arrange a student, it means it has to be boy, girl, boy, girl, boy, girl, boy, right? It has to, all right? And then using our fundamental counting principle, well, how many boy you can choose for the first one? Well, there's 4 of them. 4, 3, 2, 1. So this is how you arrange the boys. How you arrange the girls? There are 3 girls to choose from, and here we go. So using fundamental counting principle, that will be the answer, right? So 4 times 3 times 2 times 2 times 1 times 1. So the answer is 36, 156, 156. Okay. See, you can see the second question. I don't use permutation at all, right? For the second part, when there's restriction, you don't need to. Number 3, 6 actor, 8 actresses are available for a play with 4 male role and 3 female role. How many different cast lists are possible? All right. Now, you can look at it this way. For the actor, 1, 2, 3, 4. Well, you can think of it this way. So there's only 4 roles. If you choose, there's 6 people to choose from. You can choose the first row, you have 6 choices. Second row, you only have 5 and 4 and 3, right? You can look at it this way. And then for the 3 female row, right? This is the male, this is the female. You have 8, 7, 6, right? Like the question can be done by fundamental counting principle. We can also use permutation. This is how you think about it. The 6 male actor, you pick 4 of them. And remember what n is? Multiplying. You have 8 actors, you pick 3 of them. Okay, equal answer. You will get the same answer. So if you like this way, if you find it helpful, you find it is faster, shorter, easier, then you can do that. You can punch it in a calculator as well. All right, but then the P button is not very easy to punch in the calculator, so you may as well just type the fundamental counting principle. Just type the number one by one rather than using the P. Okay, anyway, now, and also for permutation combination, by looking at different types of example, just expose you to different types of question, different varieties, and then you just get better at this, right? So for a question that you have never seen before, it's very hard to figure it out all by yourself. But you have seen it, you have seen example, you have tried similar questions, then you have a better chance of knowing what to do when you're given a question. All right. Andrew were asked to determine the number of arrangement of the letters of the word brains in which the vowels are together. His reasoning is shown below. Since the vowels must be kept together, I will treat A and I as one element, AI. This means I now have only 5 elements instead of 6 to be arranged. The 5 elements are AI bound together, B, R, and S can be arranged in 5 factorial ways. So my answer is 120. Is Andrew correct in saying A and I can be combined as one element? Yes, it's a good way of thinking about this question. But the final answer is not correct. How come? Well, for this question, you have 6 letters, but since you have this condition, the vowels have to be together. Yes, you bind A and I together, so they become one. A and I become one. So the question turned into you just have 5 elements to arrange. So 5 factorial is the way to go. However, when you bind A and I together, is only just one way? Is it just AI? Is there another way? Yes, there's another way. You can also put IA, right? So for AI, you have 5 factorial ways. For IA, you also have 5 factorial ways. So the correct solution to this question is you bind A and I together, so it's become a 5 letters you need to arrange. 5 A and I become one letter, so it's 5 factorial. However, for the AI, it can also be IA. So for the AI, IA, there are 2 factorial ways to arrange them. So that will be the answer for this question. So the answer is 240. 2 factorial is just 2. Now for this question, if you need to bind 3 letters together, it's the same idea. If you bind 3 letters together, 6 letter binding 3 together, so the 3 become 1, the remaining 3 is still 3, so 1 and 3 you have 4 letters. So if this question become binding 3 letters together is 4 factorial. But then for the 3 letters that bind you together, let's say is ABC, it could be ABC, ACB, BAC, BCA, CBA, and CAB. So there are 3 factorial ways to arrange or to bind those 3 letters together. So the answer will be multiplied by 3 factorials. So the answer will become 4 factorial times 3 factorials if you change the question to that. All right, let's try example number 5. The number of permutation for this letter, kitchen, 1, 2, 3, 4, 5, there are 7 letters. If the letters K, C, N have to be together, in this order, have to be K, C, N, no other way. So together, this is just one tile, all right? And then I, T, H, and E, right? The total 7 letter, but this count as one letter, 2, 3, 4, 5. So the question just become arranging 5 factorials. Wait, just 5 factorials. The answer is 120. All right. Or the K, C, N must be together, but they can be any order. So the answer become 5 factorial, same thinking. But for any permutation of KCN, each one KCN can be arranged in 3 factorial ways because you're just arranging 3 objects. So that will be the answer. This one equal to 120, that one equal to 120 times 6. 3 factorial is 6 is 720. Okay, so this is how you do it. Basically, this is what similar to example number 4, except you're binding 3 things together rather than 2. Let's look at example number 6. Just more example, just more exposure. You be able to do work on more varieties and work more problem. Okay, Frank, George, Hannah, Isis, Jacob, and Kim have playoff tickets for a hockey game in adjacent seat K3 to K8. In how many different ways can they sit together in seats 3 to 8? So A, 3, 4, 5, 6, 7, 8. So there are 6 seats, right? So hiding from this information is that we talk about 6 seats. They just want you to think, right? From A3 to A8, how many seats are there? There are 6 seats. Well, how many people do we have? 1, 2, 3, 4, 5, 6. There were 6 people, all right? So arranging 6 people in 6 seats, the answer is 6 factorial. Or 6, 5, 4, 3, 2, 1. George and Hannah are dating. Okay, good. In how many ways of the arrangement in A would they be sitting together? If they are dating, which means they want to sit together. All right, so G and H have to be together. So this is same as example number 4. So you bind them together. Then you have, instead of 6 people, now you have 5 people. One of them is George and Hannah. So you have five people, so it's 5 factorial. But George and Hannah can be George, Hannah and George. So multiply with 2 factorial. Just before the game, George and Hannah have a disagreement and decide not to sit together. All right. That's very funny. All right. Okay, that's happened. And then how many ways in the arrangement can they be sitting apart? Okay. Now, they can be really apart, right? They are one end, right? They really hate each other now. Or they could be just like 1 seat apart, right? Or like 2 seats. So it's impossible to think of all the ways they can be sitting apart. So what do we do? Well, we can think the opposite. We can think about the way that they sit together, right? We think about all the possible way people can sit together, which is part A, and then all the way that they can sitting together, which is part B, and then what do? All right? We subtract the two number. Okay, think about it. Let's think about it. Part A, 6 factorial represent all the ways these 6 people can sit together. It includes some of the ways that George and Hannah are sitting together. It includes some of the way that they're not sitting together. It's just all the ways. All right? However, the answer in part B is when they're sitting together. So this number will be smaller than 6 factorial because 6 is factorial is all the possible ways. The second answer, B, is just the way that they can sitting together. So it's limited, so it's smaller. Now, if you don't want them to sit together, you just subtract them. Wow. Does that make sense? All right. So this one give you 720. This one give you 240. So there are 480 ways that they can be sitting apart. All right, so this is a really good question. So I put a star here, right? So sometimes you need to think about the complement. Remember this word from Unit 1? Complement means the opposite. Like 1 minus A, the set of A is the complement. So the complement and A, right? A and complement A together will give you 1, will give you everything. So same thing here. Not sitting together and sitting together, if you add them, will give you all the ways people can sit together. So now you subtract them, you get the way that they don't sit together. All right, so hope this question really helped you be able to solve permutation combination question. And then now you can try the homework. And then in future lesson, you will see even more variety, which make it very, very interesting. All right. So just work on this homework so that you have solid foundation. See you.